Hello, my name is Ehab. I'm part of Team One, along with Brian, Perkay, Chester, Robert, and Samuel. On this report, we're going through the analysis and redesign of a Weber portable propane grill. So this portable grill provides a lightweight, convenient alternative to conventional stationary grills. The grill feature component can be also easily disassembled for cleaning. So this grill provides a room for cooking up to 9 burgers at once, and the estimated annual volume of the portable propane grill is 100,000 units per year. On this slide, we're showing the exploded view. So starting from the picture on the left-hand side, top to the bottom, so we start with the top shell assembly, the grill grate, the burner, and the bottom shell assembly, including the igniter and regulator. And on the bottom, you can see the two legs that we have and the leg braces. On the picture on the right-hand side here, you can see the complete assembly where every part in its place. On this project, our primary target customer are the campers, and the secondary customer group here is the food caterers who move around from site to site and need a means to prepare food fresh as they serve their clients. According to the functional analysis, cook food is our main primary function, and in order to do that, we need to contain food through support food and isolate food, and we need to add heat through distribute the heat and convert energy, and we need to control temperature through contain heat and control energy input. We also need to assure dependability by preventing burns, and this can be done through maintain control, isolate heat, and access food. Assure convenience through maintain position, enhance portability, and facilitate cleaning, and enhance products through add comfort, and also add place sensors.
This slide contains the function component mapping matrix. The matrix shows the relationship between the individual components derived from the BOM and the basic functions that were the end nodes of the FAST diagram. All of the components serve multiple purposes. Notably, some functions such as maintain control and enhance portability are influenced by many individual components. This may indicate that these functions were an important consideration when designing the grill.
As you can see from this slide, the differentiating functions for our customer groups are contain heat, distribute heat, and access food. The common platforms for each product variant are the grill grate, gas regulator, bottom shell, support leg, igniter, and leg brace. The modules that support each differentiating function are the handle cover tops, handle cover bottoms, handle base, top shell, and burner. This slide depicts the two product variants for each customer group. The primary customer has one burner, whereas the secondary customer has two burners for higher cooking temperatures and an easy access handle at the front of the cooking box. The interfaces between each variant are common between all platform and modules.
Here you can see our product family assembly sequence for assembly sequence A. As you can see, the two product variants are differentiated once the burner is installed at the fourth step. This means that the product variants are differentiated relatively early in the assembly sequence, which is not great. Here you can see an improved assembly sequence. We decided to move the burner installation down to step 8 in order to delay differentiation. This means that for the majority of the assembly sequence, both product variants can be assembled in the same way. No part modifications were needed in order to delay differentiation.
In the design for manual assembly portion, we performed an assembly analysis for the initial design and calculated a total assembly time of 81.9 seconds as well as an efficiency of 18.32. A large portion of this comes from the top handle and the cooking grate. Using sheet metal stamping and injection molding, we can improve the design on these parts to reduce the assembly time. On the top handle, we followed design guidelines DFPH-3 and DFJ-3 and changed the design from a dual post C-shaped handle to a single post and modified the snap fit to have 90-degree symmetry. For the cooking grate, we followed design guideline DFPH-1 and changed the material to stainless steel and maximized the part symmetry. Based on the changes that were made, we reran the assembly analysis and showed a 6.5 second reduction in assembly time, as well as an improvement to 19.83% for assembly efficiency.
For design for automated assembly, we focused on the side handles of the grill. The initial design included 8 components and 4 fasteners, and the redesign included just 3 components and 1 fastener. The design changes we made were we added a locating feature to help line the parts up during assembly. We reduced the part count by removing the plastic covers that went onto the metal handle and just made the handle all entirely of plastic. And we changed the geometry to avoid overlapping during feeding. The design principles we used are shown here, and this contributed to a cost reduction of $6.47 per part.
The top handle will be manufactured using injection molding. This is based on the material, large batch size, and the lack of overhangs. In order to be manufactured using injection molding, though, the section thickness of the ball will have to be significantly reduced. The grill grate will be manufactured using sheet metal forming. This is based on the universal thin cross-section and the use of basic cutting and forming shapes.
Based on the process selection, injection molding process will be used to produce the upper shell handle. As we see in the picture, we have selected the polycarbonate with 30% glass to resist the high temperature. We also assume to have one cavity on the die, and the total volume will be 100K for the upper shell handle. So after calculating the manufacturing cost of the initial design, we went through a redesign proposals that led to a significant reduction in the cost, such as changing the material, minimized the wall thickness to 3.04, we kept the uniform wall thickness, and we also proposing commonizing the top shell handle with the two-side handle, which led to the increase of number of produced parts from 100K to 300K. On this slide, you can see a comparison between the manufacturing cost for the initial design and the redesign. As you can see in the table here, the material cost got reduced, the operating cost got reduced, and the mold cost got reduced. So overall, the total cost per part went down from $31.99 per part to $0.46 per part. The CAE shows the deflection of almost 4 mm due to the 78 Newton applied on the handle due to overall grill mass plus propane tank. We did able to reduce this to 1.9 by increasing the wall thickness by 3 mm, as you can see on the picture here.
The original design is manufactured through the sheet metal working process. The part is pierced, cut off, and then bent. The material and features in this part lead to significant cost. The proposed redesign is to change material from stainless steel to the much cheaper low-carbon steel, reduce the quantity of slots and enlarge their size, and change to a flat surface, eliminating costs associated with the bending process. The redesign dramatically reduces the material, operating, and die costs, and ultimately the total cost per part.
On the design of product service systems, there is a number of ideas can be implemented to improve customer experience and reduce at the same time the negative impact on the environment. On the identification, we found the customer will need access to replace the propane tank to enjoy using the propane grill, and there are also some hazards storing those tanks in houses due to children, leak, overheating, and such. As a concept, we design a system that the customer can go and rent the propane tank for his need and then return it back to one of our service stations. So in summary, this service will gonna reduce cost and also reduce the environmental impact. So launching mobile app, we're gonna provide a service for the customer to see the location where they can rent propane tank. Also, at the same time, increase the share use by only renting the tank for their use and return it back on the same or any other location. At the same time, we can make the propane tank out of recycled material. On the cost side of it, the customer can buy 2 tanks for $10. By having this service on, the customer can use 1 tank for $1.35.
In conclusion, our redesign of the portable grill results in a cost savings of $69.62 and a total component reduction of 6. The initial design and redesign can be seen in the pictures on the left. Our redesign also increases the efficiency of both manual and automated assembly. A couple drawbacks of our design are that no ergonomic or comfort studies were done on the handle designs, and we can't use automated assembly for all components. Moving forward, we would like to commonize the top and side handle designs to reduce the number of unique components and investigate customer willingness to assemble some components themselves to reduce our assembly costs. Thank you for listening, and we look forward to your feedback.